Hello friends, George here, welcome to the channel. Today an Atari TT video. As you can see here, I have a 3D model of a Parrot, which is quite colorful. The idea is to take this 3D model and export it to the Atari TT and render it. I have written a 3D engine for the Atari ST and for other home computers like the Commodore Plus/4, which was the first version. This version of the software could only render in 2 colors. And now this is something new. In this case, I can render with colors on the Atari TT, which is a more powerful version of the ST, which has a higher resolution. It can also display more colors, but you can also put it into ST mode. So the task of today is to render this parrot here, this wonderful parrot in color, and I will show you how I've done it. You can see the model of the parrot has faces, which are these triangles here, and you can assign colors to the faces over this material tab here. You can give every color a name. Well, I give the names which belong to the color, yellow for example, and every color has an RGB value. Here, this RGB value stands for red, green, and blue, and the value goes from 0 to 1. The idea is to mix red, green, and blue and get the color. And if I mix, 1 is the most intense value of red, bright green, bright blue, will give us white. And 0 red, 0 green, 0 blue is black, and everything between gives us the colors. Let's say here sand. Sand has a RGB value of 0.8, green is 0.237, and blue is 0.017. This is the way how you can describe colors. One way, there are many ways. This is one way, the RGB way. And I export these values here to a text file. And when I read this out, I can set the palette of the Atari ST to the color which is described exactly, and hopefully we can get a replica of this very nice and beautiful parrot. So let's switch over to the Atari TT. So now we are on the Atari TT, which is emulated with the Atari emulator. And this here is Omikron BASIC. And this is the program here which I wrote in BASIC, the 3D renderer, which supports materials from Blender. Well, I will start the render first, and then I can talk a little. So let's compile it first. And then run the compiled program. So this here are the RGB values, which I display for control purposes. I press a button here, and then the vertices are loaded. And this here is the preview mode, the dot mode. Here I could theoretically rotate, scale, and translate the model, but we don't do this now. And I press the L key and start the render. So this is a compiled version. As you can see, it's still quite slow because the data is read from the hard disk and it's not held in memory. I did this to render more big models which don't fit in memory as well. And as you can see, the parrot is rendered with the colors in Blender. So let's go a little through the code for the interested, of course. So here's the code. First of all, the code is not optimized for Omikron BASIC. You can see on the left the line numbers here. In Omikron BASIC you can of course define functions and procedures. So let me show you how I get the colors into the Atari ST. Here we have the palette SEQ file, which is basically a text file. Here we have the text file. As you can see, we have 16 lines. Each line stands for a color of the palette which the Atari ST can use. The Atari ST can only display 16 colors at once, and the amount of colors you have are 512 colors on the Atari ST and 4096 on the Atari STE. These are the limitations which these machines have. So the challenge is here to convert these RGB values, red, green and blue, into values that the Atari ST can understand. The colors which are relevant are starting at line 3 and go up to line 14. The last two lines, 15 and 16, are not used in this case because the model has only 12 colors. So let's switch over to the code again. So at this point here, we load the file with the name palette.seq, where all the RGB values are contained. This is a for loop, which is not programmed very well because it's hard-coded from 0 to 15. So the loop expects 15 colors. And if you don't have 15 colors, it will run into an exception. But okay, this is only for demonstration purposes. And this line here, input #1, I load the RGB values and the name of the color. Stands for red, green, and blue. And name $ means that this is a string, and all the other values are GAV, are real values. So integer values are, for example, if you go line 15, FBW, there is these percent. Here, this percent. This means that this is an integer value. So we need 3 bits for every color, red, green, and blue. And we put these 3 bits into a line so that we have 9 bits. And how we do this? We take, for example, the R value and multiply it with 7. R goes from 1 to 0, as I said. And if I multiply the number 7 with 1, it's 7. And if I multiply it with 0, it's 0. And if I multiply it with 0.5, I will get 3.5. So I have to round it to the next integer. And that's the reason why we have the integer in front. Why we need 3 bits. The intensity value of the red, green and blue goes from 0 to 7 on the Atari ST. So we have only 8 shades of red. 0 is no intensity and 7 is the highest intensity. So we convert the real values to integer values. Because we need these 3 intensity values of the color in a row so that we have 9 bits. The first 3 bits are for red, the 4th until 7th, 4th until 6th are for green, and the last 3 bits are for blue. And that's all the magic. This line here calculates us the integer value, which we pass over to the xBIOS function in line 17. We have 16 colors in the palette, and we define these 16 colors according to the values in the text file. This is how I have done this for the Atari ST. The STE has a little more complicated calculation of the colors because it has 16 shades of intensities of each color. The calculation of these 16 shades is a little different, but we won't go to this now. What I also have to mention here on this xBIOS function, we have 2 kinds of palettes. You can imagine it that the indices of the colors are different in these 2 kinds of palettes. We have the hardware palette. So if I change the hardware palette, I will change the color system-wide. And I have a kind of software palette, which has its own order of indices. And this here P to H percent is a kind of lookup table where I match the indices to the hardware palette. So if I call this XBIOS function, I will change the colors system-wide. So if I close this program, the colors palette will remain. Not the best solution, but this is the solution I came up at that point. So let me show you how the color is applied. This is done here. FR gets the index of the palette. So every color of the palette has an index, and I retrieve these indices from an array here, UK%. And fill color defines the color of the faces of a polygon which I draw. And here is the polygon function which draws the polygons, in this case triangles. First we draw a filled polygon with a color, and then we draw the outlines of the polygon, which is, the outline is always black, and the outline is defined with the line color at the beginning of line 2040. So friends, that's it for today. A little insight of some Atari ST coding in BASIC, Omikron BASIC. This code is not perfect, it's not optimized for the Atari ST. I hope you enjoyed the video. I certainly enjoyed making it and sharing it with you. So for the end, we will render the Parrot again. Have a nice day and see you in the next one. Bye bye.